Welcome everyone. Let's learn limit properties. Property 1. If fx is equal to c, then limit of fx as x approach to a is also c. Why? Because let's draw fx is equal to c. Let this be our c, and the graph is like this. For any point a, if we check the limit from the left and the right, we see that limit of fx as x approach to a is also c. A really simple property. Property 2, limit of c is a constant here, fx as x approach to a is equal to c multiplied with limit of fx as x approach to a. This is telling us if there's a constant in the limit, we can take it out of the limit. For example, limit of 3 multiplied with x squared minus 1 as x approach to 5. First, we need to take the constant out. 3 times the limit of x squared minus 1 as x approach to 5. How do we evaluate this part? We will just plug the 5 in. 3 multiplied with 25 minus 1. 24 times 3, 72. Property 3. Limit of fx plus or minus gx as x approach to a can be written as two separate limits. If we have sum or difference of functions inside the limit, we can take limits of them separately, which will also be equal to a plus minus b. What do we mean? We are assuming this is equal to a, this limit is equal to a, and this limit is equal to b. Example, limit of x squared plus sine x plus 10 as x approaches to 1. You can just plug 1 in, of course, why not? But let's use the property, since we are learning it. X squared as x approaches to 1 plus limit of sine x as x approaches to 1 plus limit of 10 as x approaches to 1. Plug this in, 1 plus plug this in, sine 1. For limit of 10 as x approaches to 1, we have 10 from our first property, 11 plus sine 1. Property number 4. Limit of fx multiplied with gx as x approaches to a can be written as two separate limits again. Of course, our answer will be a multiplied b. Again, we assume this limit is equal to a and this limit is equal to b, so therefore the answer is a multiplied with b. Example, limit of sine x multiplied with 3x as x approaches to pi over 2. Let's write this as limit of sine x as x approaches to pi over 2 multiplied with limit of 3x as x approaches to pi over 2. What is sine pi over 2? It is equal to 1. 1 multiplied with 3 pi over 2. This limit is equal to 3 pi over 2. Property number 6. If we have division of two functions in a limit, we can first evaluate limits of these functions separately as x approaches to a. Then our limit will be a over b, only if b is not equal to 0. Because if limit of gx as x approaches to a is 0, this limit, we cannot work with that, right? We did not learn indeterminate forms yet, but we don't know what a over 0 is. From high school, we know that this is undefined. We talked about these in high school. Limit of x minus 5 over x squared plus 6 as x approaches to 3. Let's use our property. Limit x approaches to 3, x minus 5 over limit of x squared plus 6 as x approaches to 3. Plug the 3's in. Negative 2. 3 squared is 9 plus 6, 15. Negative 2 over 15. Be careful, our denominator is not equal to 0, so we could use the property number 5. But if our denominator was 0 after plugging the 3 in, we could not work with this. You don't need to write it separately like this every time, obviously. You can just plug it in the limit, but since we are learning properties, I am going step by step. Property number 6, limit of nth root fx as x approaches to a is equal to nth root limit of fx as x approaches to a, which is also equal to nth root of a if nth root a is defined. We don't have an example for this property because I forgot to write one. Let's make an example. X approaches to 3 root x squared minus 5. To evaluate this limit, from the property we have, we can write limit of x squared minus 5 as x approaches to 3. Plug the 3 in, 9 minus 5, 4. So this is equal to root 4, which is also equal to 2. Some problems we have, really simple from what we learned. We will just keep using the same properties. Limit of 5x as x approaches to 2. We can write this as 5 limit of x as x approaches to 2. Plug the x in, 5 times 2 is equal to 10. Limit of 2x plus 3 as x approaches to 2, you can just plug it in, 2 times 2 plus 3, which is equal to 7. Limit of x squared minus 4x plus 1, plug the 2 in, 4 minus 2 minus 8 plus 1, which is equal to negative 3. Let's see. We have a fraction, so we have to be careful. Is our denominator 0? No, it is not. Therefore, we can plug it in. 2 squared minus 4 over 4. Our numerator is 0. Therefore, this division is equal to 0. Limit of root 25 minus x squared as x approaches to 4. We learned that we can send the limit inside. Instead of writing everything down, let's just plug the 4 in. Root 25 minus 4 squared is equal to 3. Limit of x cubed plus 2x squared minus 1 over 5 minus 3x as x approaches to negative 2. In these fractions, the first thing I have to check, no matter what, is my denominator 0 when I plug the x value? Plug the negative 2, 5 minus, so 3. Our denominator is 11. Therefore, we can plug it in. Negative 2 cubed plus 2 multiplied with negative 2 squared minus 1 over 5 minus 2 multiplied with 3. Negative 8 plus 4 to 8 minus 1 over negative 6 plus 11, which is equal to negative 1 over 11.